Hello viewers, in today's session we are going to discuss another important concept from sphere, and here we are going to discuss the concept of tangent plane to a sphere at a given point, right? So here we'll discuss this concept with the help of this problem where we have to find the equation of the plane tangent to the sphere whose equation is given by this second degree equation x square plus y square plus z square minus 2x minus 4y plus 2z minus 3 is equal to 0, and we have to find the equation of the tangent plane to this sphere at this point, that is minus 1 comma 4 comma minus 2, right? So let us start. So let us now consider a rough diagram of this problem, and here we have a sphere and whose center is say O, right? And let us draw a plane like this. This is a plane, and this plane is tangent to this sphere at this point, right? And let us call this point as point P, right? And this point P is known as the point of contact, right? So point of contact is the point where a sphere touches a plane, and here we are given the coordinates of the point of contact P as minus 1 comma 4 comma minus 2, right? And the equation of the sphere is given as this, right? Okay, so now we have to find out the equation of this plane P, which is tangent to this sphere at this point P, right? So now let us consider the general equation of a sphere as x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0, right? And let us consider the equation of this plane as say ax plus by plus cz is equal to say d1, right? And the center of this sphere is given by the coordinates, that is minus u, minus v, and minus w. So the coordinates of the center of the sphere is given by minus u comma minus v comma minus w. So now let us compare this equation with this one. So here we have 2ux, and here we have a minus 2x. So 2u is equal to minus 2, and here we have 2vy, here we have minus 4y. So 2v is equal to minus 4, and here we have 2wz, and here we have 2z. So 2w is equal to 2, right? So from here we have u is equal to minus 1, because minus 2 over 2 is minus 1. From here v is equal to minus 2, and w is equal to 1, so that minus u is equal to 1, and minus v is equal to 2, and minus w is equal to minus 1. So the center of this sphere is now given by the coordinates 1 comma 2 comma minus 1. So here we can write 1 comma 2 comma minus 1. So now the next step is to join the point O and the point P, right? So when we join this point O and this point P, then OP is perpendicular to the plane, right? Or the tangent plane. And here O is the center of the sphere and P is the point of contact, right? So now OP is perpendicular to this plane. So let us find out the direction ratios of OP, right? So to get the direction ratios of OP, let us consider the point O as x1, y1, and z1, and the point P as x2, y2 and z2. So the direction ratios of any vector joining two points may be obtained by subtracting the coordinates. So we have x2 minus x1, then we have y2 minus y1 and z2 minus z1. So now we can write the direction ratios of OP as -1, -1, and then we have y2 is 4, so we have 4 minus 2, and then we have z2 is equal to -2 minus minus 1. So we can now write here -2, this is 2, and this is -2 plus 1, that is -1. So the direction ratios of OP are -2, comma 2, comma -1. So now let us draw the normal vector to this plane P, right? So the normal vector of this plane P may be drawn like this. And from this figure, we know that this normal vector is perpendicular to this plane, and OP is also perpendicular, right? So OP is perpendicular to the plane. It implies that this normal vector n is parallel to this line, that is the radius, that is OP, right? So vector n is parallel to OP. So this implies that the direction ratios of the normal vector to this tangent plane are same as the direction ratios of OP, right? Because from vectors we know that if two vectors are parallel, then their direction ratios are either equal or proportional. So the direction ratios of vector n may be taken as -2, 2 and -1, right? So now we are in a position to find out the equation of this tangent plane, because we know a point P which lies on this plane, right? And it is important to note that this point P, it also lies on this sphere, right? Okay, so now the equation of any plane which passes through some point, say x1, y1, z1, and having direction ratios a, b and c, is given by a times x minus x1 plus b times y minus y1 plus c times z minus z1 is equal to 0, where a, b, c are given by -2, 2 and -1, right? So here we have now a -2, then we have x minus x1, x1, y1, z1 may be taken as this point P, which is -1, 4, comma -2. So here we have -1, then B is 2, and y minus 4, y1 is 4, and then C is -1, and Z minus 2, and this is equal to 0. So now we can simplify this equation. So we have -2, this is x plus 1. Here we have 2y minus 8, and this is -1, and z plus 2 is equal to 0. So from here we can now write -2x, then we have -2 plus 2y minus 8, and then we have minus z minus 2 is equal to 0. So this is -2x plus 2y. Here we have minus z, and this is -2 minus 8 and -2. So this is -12, right? So now multiplying both sides by -1, we can also write this equation as 2x, and then we have -2y, and then we have here plus z, and plus 12 is equal to 0. right? So this is the required equation of the tangent plane to this sphere where the point of contact P has the coordinates -1 comma 4 comma -2.